When we talk about modern AI systems like ChatGPT, we often hear that they run on GPUs inside massive data centers. That naturally raises a question. Why do AI data centers need GPU at all? Why can't they just use CPUs like normal computers? After all, CPUs have powered our laptop, servers, and the internet for decades. So, what exactly changed when AI entered the picture? To understand this, we first need to look at what data centers were originally designed to do. For a long time, data centers were built almost entirely around CPUs. Their main job was to handle everyday internet tasks, things like opening web pages, sending emails, running databases, processing payments, and responding when users clicked something. What's important is that these tasks are all decision based. Each request is slightly different. The system has to check conditions, make choices, and then move to the next step. This kind of work happens step by step. CPUs are very good at making decisions, following different paths based on conditions, and switching quickly between many small tasks. That's why for decades, CPUs were more than enough to run the internet as we knew it. A good way to understand this is by looking at how Google search worked before generative AI. When we searched something on Google, the system was not creating a new answer from scratch. It was mainly finding information that already existed. Google had already done most of the hard work earlier. It had scanned the web, stored copies of web pages, and built massive indexes in advance. So, when we typed a search query, Google's job was fairly simple. It just had to look up relevant pages from its index, decide which ones were most useful, and show us links or short snippets. Because most of the work was already done beforehand, each search required very little computation at the moment we asked the question. The system was mostly making decisions, ranking results, and choosing what to show. And that is exactly the kind of work CPUs are very good at. That is why search engines were able to handle billions of searches every day using mostly CPU based data centers. Generative AI systems like ChatGPT changed this approach completely. Instead of finding information that already exists, these systems create a new response every time you ask a question. When you ask ChatGPT something, it does not search for a stored answer. It builds the response step by step, predicting one word at a time based on patterns it learned from huge amounts of data. To generate each word, the system has to send information through large neural networks, do a massive number of calculations, and constantly evaluate and predict which word should come next. And this process repeats again and again for every sentence. This kind of work is very different from what search engines were doing. Search engines were mainly making decisions or choosing between options. ChatGPT and AI models are about performing the same type of calculation repeatedly at a very large scale. That is why each AI query requires more computation and why this kind of workload no longer suits CPUs. Now, the real shift that AI introduced is the move from search engines to generative AI. It's not just a change in software, it's a fundamental change in the type of computation being done. Search engines scaled well with CPUs because they focused on retrieving and ranking information. Generative AI forces data centers to move towards GPUs because it generates information through heavy parallel computation. And that is why modern AI infrastructure looks so different from the data centers of the past. You can think of a CPU like a very intelligent worker. It's great at handling complex tasks, but it mostly works on one thing at a time, constantly switching between different responsibilities. That makes CPUs very powerful, but it also makes them inefficient for AI workloads. Running large AI models on CPUs is like asking a few brilliant engineers to move an entire mountain by hand. They understand exactly what needs to be done, But the problem isn't intelligence, it's scale. The task demands an enormous amount of work happening at once, not just smart decision making. GPUs were built for a completely different purpose. Originally, GPUs were designed for graphics, for example, drawing millions of pixels on a screen at the same time. To do that, a GPU is built very differently from a CPU. Instead of having a few powerful cores, a GPU has thousands of smaller cores where each one does a simple calculation and all of them work at the same time. So, if a CPU is like one highly skilled worker handling tasks one by one, a GPU is more like an entire army of workers all doing small parts of the same job simultaneously. That is what we called working parallelly at same time. And this is exactly why GPUs are so good at AI. AI models rely heavily on a type of math that can be split into many smaller pieces. Each individual calculation is not complicated, but the total number of calculations is enormous. And GPUs are designed for exactly this kind of work. They can run thousands of calculations in parallel across huge amounts of data for more efficiently than CPUs. So, when large AI models entered data centers, the architecture had to change. Data centers shifted from being mostly CPU based to becoming heavily GPU based. And that's why modern AI data centers look completely different from the traditional server farmers of the past. This GPU requirement shows up in both major phases of AI. The first phase is training. Training is when the AI models learns from huge data sets. It adjusts billions of internal values again and again until it becomes good at predicting patterns. This process is extremely heavy. GPUs often run continuously for weeks, sometimes even months during training. And this is usually the most energy intensive part of building an AI model. The second phase is inference, which is a phase we experience as users. Inference is what happens when you open ChatGPT, type a question, and get an answer. At this point, the model is already trained, so it's not learning anymore. But it still has to do a large amount of computation to generate each response. Even a small text reply, even a sum- Even a simple text reply requires the system to run through a large neural network and predict the output step by step. So, inference uses less power than training, but it's still significant, especially when millions of people are using AI at the same time. Now, when you put all of this together inside a real data center, the scale becomes huge. This is not only one GPU running, but thousands of GPUs running at full load and enormous amounts of data constantly moving between processors and memory. This produces heat continuously, and that heat has to be removed 24/7 all the time. So, cooling systems have to run non stop. This is a very important point. Electricity is not only consumed by the computation, but a large portion is also consumed by cooling, power delivery, and the supporting infrastructure that keeps the whole facility stable. That is why AI data centers are now being discussed in the same category as power grids, energy policy, and in some cases, even nuclear power. AI is no longer just a software topic, it has become an infrastructure and energy problem. One important clarification is that CPUs haven't disappeared. Even in modern AI data centers, CPUs still play a critical role. They handle things like moving data around, coordinating tasks, and controlling the overall system. You can think of it like this: GPUs do the heavy mathematical work while CPUs manage everything happening around them. So it's not really GPU instead of CPU. It's GPU has become essential because AI workloads demand massive computation. And this leads to the bigger picture. AI progress is not driven only by the better algorithms. It is equally driven by things like hardware design, data center architecture, energy availability, and even physical limits. AI looks simple on the surface, just a textbook and an answer. But underneath that simplicity is something very different: massive parallel hardware, enormous electricity consumption, and industrial scale computation. So, when we say that AI data centers need GPUs, we are not really talking about making computers smarter. We are talking about matching the nature of the work to the right kind of machine. AI is powerful not because it thinks like humans, but because it's supported by machines built to do an extraordinary amount of maths all at once. If you like this kind of simple explanation of what is happening behind AI, consider subscribing. Thank you.